Good morning, good afternoon, good evening, depending on where you're watching me from or what time you're watching this video. So yeah, I've been out for a while, but I was working on something. So I've made this is an inverter. Input is 24 volts. 24 volt. This is a DIY battery. Yeah. Then we have the inverter itself. Yeah. I've been so eager to go off grid, so but now when I check the price of such inverters, they are very costly. But this is just the part 1 of the video. There will be more parts. So this inverter is 3.5 kilowatt. That is what it can support, but as at now, because of the transformer I'm using, it is a low frequency inverter. Those who know low frequency inverters think you know how good they work, because they can work even at 150% of an inductive load and they will be perfectly fine. So yeah, so now let us get back. So for this inverter, the input is 24 volts minimum, then output is 220 to 40 volts pure sine wave. Yeah, then for the transformer, as at now I'm using a 1.2 kilowatt transformer step up. Then the battery which I have is not so powerful. It is just only around 30.5 Ah, 24 volts though. Yeah, you can see it has a BMS. There is a BMS. Yeah, okay. So this is the part 1. For the part 2, I'm going to make an mppt, a charge controller, which can take in up to solar of up to 100 or 90 volts. Then you can select in between the settings to charge your battery. Yeah, so as at now, the inverter does not have capability to reach its full potential. The problem is the transformer is a 1.2 kilowatt. Although I want to get a new transformer, just looking for some cash. When I get the cash, I'll go on and use purchase a bigger one which will support up to 3.5 kilowatt. Yeah, then you can see the output is here. Yeah, then we have this inductor which should be put in between the TX transformer and the outputs. Yeah, the module which is controlling is this GS002. Okay, so let's go on and let me test and maybe power 1 or 2 loads. I'm eager to go off grid. I love off grid life because you don't owe anyone an explanation of why or when you want the power. Yeah, the power is just natural because you'll be using solar to charge your batteries. Then from the energy stored from the batteries to your inverter to your appliances, pure sine wave. It has a feedback. If you know more about the GS002, you know how it works. So the efficiency, I've not yet been able to measure it up. I'm in the process of doing that, and maybe I'll try. Okay, what I've measured is the idle current. The idle current is very low, 400 milliamps. That is what is consuming when idle. Yeah, I'll measure that for you just now. So let's go to the operation and let us check how it works. Let us test the inverter. Okay, let me show you first. So here is the input. Here, this wire and this wire, these are 2. Yeah, from the battery. There is no other wire here in between. So then the output to the transformer, you see these green wires, this one green wire and these other green wire, these are to the transformer, you see them. So after the input from the battery, then these are the two green wire to our transformer. Then from our transformer output, is our output. Here you see, here's our output, this. Then the output has a feedback to monitor the voltage. If it is kept at 220, it should stay at 220. Yeah. So okay, here's my multimeter. I want to switch it on, then try and power our load and show you how much is being output. So the multimeter, let us put it to AC. Yeah, it should give the AC voltage and the hertz, yeah, of which it is a 50 hertz, 220 or 230 volts. So let us see. Okay, so let us switch on the inverter. At the moment, you see there is no, it is on a 0 here. So I'll switch on with this switch from the inverter here while my hand is on this output. So the good feature with this is that it has a soft start, so it cannot harm your appliances. So the soft start, let me show you the soft start. The voltage go increasing from 0 all the way upwards. Till the last volt. So sorry, yeah, you see, yeah. Here's the output, 27 volts. Yeah, you see, it's maintaining there. So let us try and power maybe a bulb from this to 27 volt. Here is the bulb. Yeah, okay, power it. You see, we have power. Yeah, here it is, we have power. Okay, so the next thing, I want to power my computer here. You see my computer is not on. This is its power cable. Right, it is not connected to anything yet, so even if I switch it on, it will be nothing. So let me put this one, yeah, then switch on my computer, my desktop. Yeah, my desktop is on. Let me show you. You see, my desktop is on. There you have it. You see, it's on. So where is it powered from? From our inverter. So is our inverter output. Yeah, you see, from the transformer. Here's the transformer. Here. Then I've powered my computer. Yeah. So now let us check the idle current. So far these probes are not on power. Yeah, they are not on power, so it will show 00. Okay, let us see when my computer is powered if the voltage will go down. Okay, so here it is. Yeah, so let's measure the voltage coming out. Okay, so it's still 226 volts, so there's nothing which has gone bad, and you can see it is 50 hertz. You see. Okay, if we add more load, let us add more load. Let us add this bulb and see if it will fluctuate. We add this. Yeah, we have that. And now let us measure again and see. Still at 226 volts, so there is nothing which is going bad. You see, it maintains there due to the feedback. Yeah. Okay, so let us now see. Okay, let me first power off. If I remove this, my desktop will switch off. You see, they are switched off. So let us see the idle power, which this one is idle current, which it is consuming when it is not working. That is what amazed me, and it was so nice to see. So I want to measure the current. So from the battery to the inverter. So I'll put my multimeter on the milliamps. Then ensure there is no load here. Then, okay, as you can see, then put my probes in series with the input. Yeah, yeah, then here. So now I want to switch it on. Then I proceed to switch on here. As you can see, it consumes roughly 400 milliamps while idle with no load. Say 400 milliamps. So this is a big achievement for me. If you do the calculations, 400 milliamps, that is 0.4 times 24, that is less than 12 watts, of which for me, for a 3.5 kilowatt inverter, that is the biggest achievement I can say I have made. Next is explaining the circuit, and after explaining the circuit, then move on to making the MPPT. You see, the current is maintaining there 395 to 400 milliamps on idle. Yeah, so I think the low frequency inverters in the market, I've never seen such an idle current. I'm very pleased